Okay, good morning. Maximum work done in isothermal reversible expansion. Work can be done reversibly or irreversibly. Mechanical work is said to be done when gas is compressed or expanded against pressure. Work can be done reversibly or irreversibly. Mechanical work is said to be done when gas is compressed or expanded against pressure. In the reversible expansion, the work done by the system is against the external pressure decrease infinitesimally slowly. If the reversible expansion, the work done by the system is against the external pressure decrease infinitesimally slowly, such that the change in pressure at two successive points is not much different, and hence the work done is maximum. In the reversible expansion, the work done by the system is against the external pressure decreased infinitesimally slowly, such that the change in pressure at two successive points is not much different, and hence work done is maximum. On the other hand, in an isothermal irreversible expansion, the pressure is suddenly decreased and the gas expands against new pressure, which is obviously lesser than the initial pressure. On the other hand, in an isothermal irreversible expansion, the pressure is suddenly decreased and gas expands against the new pressure, which is obviously lesser than the initial pressure. In this case, work done is somewhat less than that in the reversible case. This fact is justified mathematically as well graphically. Mathematical verification of maximum work done is isothermal reversible expansion. The work done in isothermal reversible expansion is given by W reversible equal to minus nRT ln P2 over P1. So we can write W reversible equal to nRT ln P1 over P2. Adding and subtracting 1 to the ln value. So we can write W reversible equal to nRT ln 1 minus P1 over P2. We know that 1 minus x equal to minus x square over 2, minus x over 3 and ln1 minus x equal to minus x. From equation 2, W reversible equal to nRT ln1 minus 1 as P1 over P2, equation 2. So W reversible nRT minus 1 minus P1 over P2. And solving, we get W reversible equal to nR2 P1 minus P2 over P2, equation 3. The work done is, the work done in isothermal reversible expansion is given by W irreversible nRT P1 minus P2 over P1, equation 4. Subtracting equation 4 from equation 3, W reversible minus W irreversible, and solving, we get W reversible minus W irreversible equal to nRT P1 minus P2 whole square over P1 over P2, equation 5. Since P1 minus P2 square is always positive, either P2 is greater than P1 or P1 is greater than P2, the quantity W reversible minus W irreversible has positive value, that is W reversible is greater than W irreversible is positive. So that W reversible is greater than W irreversible. This fact also justifies that work is a path-dependent function or work is not state function because the value of work depends upon the nature of the part. Work done in reversible part is always greater than work done in irreversible part. Graphical verification of maximum work done in isothermal reversible expansion PV diagram, pressure, volume. Isothermal reversible expansion P1 V1, P2 V2. A, B, C, D, small area A, B, C, D. Isothermal irreversible expansion of ideal gas when pressure is decreased, P1 to P2, P2 to P1 V2, P2 V2. Where dV is this infinitesimal increase in volume due to infinitesimal decrease in pressure. Okay, figure isothermal irreversible expansion of ideal gas when the pressure is decreased from P1 to P2. A P1 V1, B P2 V2, volume, pressure versus volume. For a given initial and final state at constant temperature, the work done by a gas is maximum when the work expansion is reversible. Let P1 and B1 be the initial pressure and volume of the ideal gas. For the reversible expansion of ideal gas, the external pressure is infinitesimally decreased, A to B, and the volume is increased corresponding due to C. Then the work done by the ideal gas dW, P1 dPe dV, where TB is infinitesimal increase in volume due to infinitesimal increase in pressure dP for the reversible process. The pressure at the point C and D are almost same. So P1 minus dP tends to P1, so that dW equal to P1 dV. This quantity of work done is equal to the shaded area ABC in figure A. In this figure A, the total work done by the gas when the volume change from B1 to B2 will be equal in magnitude to sum of the areas of all such infinitesimal area such as ABCD. Hence, work done B1 to B2 PdV equal to area ABCD. For the irreversible expansion of ideal gas, the external pressure is suddenly dropped from P1 to P2 and gas expands against the new pressure P2 from volume P1 to P2. In this case, the work expansion W equal to P2Vd. So P2 is constant during expansion and total work is given by the BCD as in figure B. Work done W equal to P2, B1 to B2, dV. So P2, B2 minus B1, area BCD. From the above graphs, it is obvious that work done in isothermal reversible expansion is greater than work done in isothermal irreversible expansion because the area ABCD is greater than the area BCD.